Okay, so okay, so this lecture is a tiny bit out of place just because of the way we missed two lectures because of holidays, right? This quarter or this session, which for summer session is a lot of lecture time, and so in a normal summer session, this would have been covered before the midterm, and this stuff would have made an appearance on the midterm. But this stuff, I'm going to cover it now because I think it's important and we need to cover it. But obviously, it did not appear on your midterm, and I'm not going to put this stuff on the final either. And I'm also not going to give you a homework on it either. So there, just because I've had to make some adjustments for this quarter just because of the way the holidays lined up, and we lost some class time and things like that. So but anyway, what we're going to have this week, there's going to be a bit of a shift. Okay, so the first half of the course is really in on like advancing your R programming skills and covering certain programming topics in R. And then the second half of the course will be a little bit more on statistical computational statistics, where there's algorithms, and we're going to talk about root finding methods and some optimization stuff, and floating point arithmetic, and so the final exam is going to kind of cover everything from the second half of the course. And so the final exam is going to be very, very, very different from the midterm exam. The midterm exam was very focused on R coding and programming, stuff like that. Final exam is going to cover more these I don't know, these conceptual ideas regarding algorithms and stuff like that. So today's lecture, does fall more on the R programming side, and it's just a tiny bit out of place. I think there's really good material here, so I am excited to cover it, but yeah, didn't appear on your midterm exam, and I'm not going to have a homework assignment on this topic here either. So it's going to kind of be here, and I will cover this, and I think it'll be useful for you. But when students are like, do I have to know this for the final and stuff like that? Yeah, I hate to say it, but no, you don't have to learn this stuff for the final exam, okay? But I think just for your understanding of R programming, learning object-oriented programming systems is important. I also have a few slides on ggplot, and I don't even know if I'm going to have time to get into it today, to be honest. But again, I'm not going to be testing you on it. And some of you have already covered ggplot in Stats 20. Some of you did not. So I don't know. I don't know how to. ggplot, I think, is great. And well, the next homework will incorporate ggplot. So if I don't get to it in today's lecture, you'll have to kind of consult these notes yourself as far as getting that homework part done. But I think my notes are pretty good. And if you have to do that, I think the notes will serve as a decent guide for getting through ggplot. All right, but anyway, we're going to talk about object-oriented programming. And depending on your programming background, you might already be familiar with certain object-oriented programming schemes. So if you take something like, in Pick 10A, do they cover OOP, object-oriented programming for C++? Or is that more like a Pick 10B thing? Anybody? I don't know. Okay. Well, if you've done C++, depending on how far you got, there's object-oriented programming stuff there. Python is very much an object-oriented programming language. A lot of other languages, Java and stuff like that, they have these object-oriented systems. And R has an object-oriented system as well. R has multiple object-oriented systems. And R's object-oriented system is very different from, say, Python's object-oriented system. And so, we have to we're going to cover that. And there's actually I guess four OOP systems. Yeah. Well, anyway, okay, let me talk about this. Okay, so we've got OOP, style of programming that focuses on defining what we call different types of objects and functions. These are like classes and methods and functions that can be applied to those object types. And it's a little bit tough in R because we've got four systems. We've got S3 and S4, RC and R6. And you know what we're going to cover in our classes, we're going to cover S3, and I'll also talk about R6, okay? People have different opinions about what's most important in R. Hadley Wickham has the opinion that S3 is the most important, and I would agree. And we'll cover S3, and then I'll just briefly mention, you know, S4 and RC. And then we'll also take a look at R6, which is good too, okay? So S3 and S4 uses a paradigm called the generic function OOP, whereas RC and R6 use what we call encapsulated OOP, okay? And yeah, it doesn't, we'll get into that, okay? So basically, we have these objects, and the objects are used to kind of store information, and then we interact with the objects, okay? We have the objects do stuff, and the functions that do the stuff with the objects, those are called methods, all right? So, you know, a lot of the other languages, like if you learn other languages, you're gonna probably encounter encapsulated object-oriented programming, and they have kind of these systems and principles, you know, these principles of encapsulation, you know, so that, you know, the way you interact with these objects and things like that. And encapsulated OOP, I think, is a very good system, and it works well. And if you're learning Python and things like that, right, you know, you learn encapsulated OOP there, and it's great. And you know, when you call a function, say in Python, you're going to call it like this. You have the object name, object.method, right? So if you're learning Python, you might have a list, right? And you're going to do like list.append or list.pop or things like that, right? And you got these, you have the object name dot the method, okay? And this this encapsulated form, you know, the object encapsulates the data in different kind of what we call fields there, and then and the methods, which do the kind of the behaviors, right? And so if you have an encapsulated OOP object system, you might think of, okay, you have a camera, right? You got a camera object, and what can you do with the camera? So the camera is going to have fields, information in it, like how many pictures have been taken and how much memory is available and things like that, right? And then the camera will have methods or verbs, things like shoot a photo, or, you know, focus, or record a video. And these are going to be the verbs that that the camera can do, okay? And there you can actually do encapsulated OOP in R via the R6 package or reference class and object-oriented systems, okay? But most of R uses the S3 system, which is what we call a generic function object-oriented programming system, okay? And in generic function object-oriented programming, okay, the methods belong to generic functions. So you have objects, and they store data in fields, okay? But the objects don't have method information. They don't have information about the verbs or the things that can be done, right? And so instead, when you run a function, the function looks at the object, and depending on the object, the function is going to behave differently, right? So one way you can think about this is you can think about the verb shoot, right? So we have the verb shoot, and this word shoot, the verb shoot, takes different meanings based on the object we're talking about, right? So if I give you a camera and I say shoot it, you're going to take a picture with it, right? You're going to take a picture with your camera, right? If I give you a hockey puck and I say shoot it, you're going to try to find a stick and you're going to try to hit the hockey puck towards the goal, all right? if I give you a gun, okay, and I say shoot it, you're gonna pull the trigger. You're gonna aim at something and pull the trigger, right? You can talk about shooting the breeze, and that just means to kind of chat idly and things like that, right? So in generic function object-oriented programming, the function or the verb depends on kind of the subject or the object that is being given to it, okay? And so we call these functions that behave differently based on the object or the input type, we call that a polymorphic function, right? It takes different forms, multiple forms, polymorphic, right? And so the S3 and the S4 systems in R use generic polymorphic functions. And basically in base R, so base R incorporates some object-oriented stuff already, like for example, a factor, right? When you build a factor in R, it's actually an S3 object, okay? And it's all done in this S3 system. So here's an example, okay? We have the function summary, right? So we use summary, and depending on what you give it, the behavior of summary is different. So for example, we have a data frame, diamonds, and inside diamonds, you have a column caret, right? So if I do diamonds $caret and I ask summary of diamonds $caret, it gives me this summary. It says the min is this, median is this, mean and max, and it gives us a numeric summary, okay? And you can also, there's another column, diamonds $cut, and this is a column, this is a factor, okay? And it has, diamonds have, the diamonds data set, and it says these diamonds are cut very good, and these diamonds are cut premium, and these diamonds are cut ideal, and stuff like that. And if you ask for a summary there, it's going to give you a count of basically each category. And so the way this function summary works changes depending on the input you give it, right? And so, some of the most common polymorphic functions that we encounter, we use all the time, like print. The way print works is it prints out different objects, and how those objects display depend on the object you give it, right? You have plot, and you can put different things into plot, and R tries to plot it, right? And then, here's the example with summary. So those are examples of polymorphic functions, and polymorphic functions are great because you can just call the function, and you don't need like special names for the functions, because then there's just going to be like way too many function names to remember, right? Already, as a part of the learning curve of R is like learning all of these function names. And so, you learn the function summary, but could you imagine if it was like summary quantitative versus summary factor or something like that, and you have to like remember all of these, or summary numeric or things like that. You have to remember all of these things, okay? It would be even more troublesome, okay? So the way these object-oriented systems work is they work off of these ideas of what is a class and what is a method, okay? A class is basically a type, a class of an object, right? And so a class is going to contain fields, which we use to hold information that's important for the class. And then a method is a specific version of a function or an implementation of a function for a specific class, okay? So a class will define what the object is, and a method will define what the object can do. And then another big idea in object-oriented systems is this concept of inheritance, right? So sometimes you have a class defined, and then you want something that looks almost exactly like that class, but just slightly tweaked, slightly a little bit different. So rather than having to define a whole nother class with pretty much all of the same kind of information, you can just say, this new class is going to inherit from the other class, okay? And so you'll get kind of this hierarchy, and you'll say, here we have this class, I don't know, linear model. And then we have a, kind of a specific version of the linear model we might call the generalized linear model, the GLM, which behaves, in some ways behaves like the linear model object, but in other ways, has additional features and things that do things differently. And we can say, that child class inherits from the parent class, right? Oh, so here's an example. You have an ordered factor, which inherits from a regular factor, right? And then, oh, we've seen tibbles before, and tibbles are pretty much data frames, but they behave a little bit differently. And so a tibble inherits from a data frame. Okay. And then, and so this concept of how, how the functions behave differently depending on which class object you give it, that's something called method dispatch. Method dispatch. You have generic functions, or we might call these things just generics, and you call the generic function like summary, and then you give it a certain object, and then R has to figure out, right? There's a little bit of thinking here that says, oh, you gave me a numeric vector, therefore the summary function is going to behave this way. You gave me a factor, therefore the summary function is going to behave this way, right? In the same way, if I gave you an object and I said, shoot it, your brain would have to look at the object and you say, well, what is this thing? Oh, it's a camera. Okay, I'll shoot it and I'll take a picture. Okay. And if I gave you, if I gave you a coin, right, and I said, shoot it, you'd be confused. You'd be like, what? What am I supposed to do, right? Like, shoot is not normally a word used with a coin. And so your brain is going to have to figure out like what you're supposed to do with it. And that's kind of method dispatch, where you have the word, or you have the function, and then you have the object, and R has to figure out what's the appropriate action to take, right? And so that's method dispatch, right? You have a generic function, and how it works depends. Okay. All right. And so the base R has these 3 object-oriented systems, right? You have S3, you have S4, you have RC, which is short for reference classes. And then we have R6. You have to load a library. You have to call library R6, which is similar to reference class RC, but I would say it's more elegant than reference classes. And so we will take a look at these things. All right, let me go ahead and give you your first view quiz answer for today. Week 4, Monday, first view quiz answer is the letter E. E as in elephant, E as in elephant. This is our second Monday lecture of the entire session. We had one on week 1, and then we didn't have one week 2, we didn't have one week 3, and now we have it in week 4. And there's pros and cons to that. I don't know. I imagine you guys enjoyed your Monday days, holidays and days off, probably. I guess it's all upside for you, because this stuff didn't show up on the midterm exams, and I told you you're not going to be tested on the final. So so a little bit of upside, but just yeah. Okay. Well, anyway. Oh, and then it's worth mentioning base types, right? So base types are kind of your internal structures, like your the atomic vector and stuff like that, right? That's a base type. That the atomic vector for integers and atomic vectors for logical values and stuff like that. They're not part of the object-oriented programming systems, but your OOP systems are built out of base types, and so it's important what we understand those things, right? Okay, so under every object-oriented system, or in R at least, all of the object-oriented programming stuff is built out of base types. Okay, it's all built out of base types, right? And so so anyway, let's see. So base types are not considered object-oriented systems because only R can create new base types, and new base types are added very, very, very rarely. Like it just doesn't really happen, right? So that maybe it only happens on like these major R releases, right? When right now we're at R 4 point something something, okay? Probably we're not going to see another base type. I can't imagine for a while. Okay, but anyway, we've covered a lot of these things, like your atomic vector types, your logical, integer, character, things like that. Double, and then lists. Those are also base types. But then they also have, you also have functions are important when we covered those. Environments, we covered those. There's a few more, like there's a name, names, calls, and promises. Those are also base types. And you can always kind of figure out the base type by asking for type of, okay? So the mean is a function, and when you ask for type of, it's a closure. And that's, it's a function. Whereas, there's also built-ins. They're called they're also known as primitives. And these are like named all kind of funny. That's, whatever. It's not a big deal. Okay. But anyway, all this other stuff, you have a function called is.object. Okay. Is.object. And so, everything, all of the objects are kind of built out of base types. So S3 objects can be built on top of any base type. Okay, S4 objects use a special base type, and then reference class objects are a combination of S4 and environments. Environments is another base type. Okay, and the difference between a base and object-oriented object is that these objects have a class attribute. Okay, if it's a pure base type, it's not going to have a class attribute. So if you ask for like a factor, you can ask what's class factor, and you ask for the attributes. All right, so let me just kind of show you here. So if I say let's do so here we have x. X is this, and if I do it's on x, there's nothing there. Okay, let's create a factor. That's right. So we have here y is a factor, and if I ask for attributes on y, okay, it has a class attribute, right? So if I ask for this, it comes with a class attribute, and so we can do is.object x. That's not an object. X is just a base type character, and I can do is object on y. Y is the factor, and that's going to be true. Okay. All right, but anyway, that's what we have here. Okay. All right, so let's do this. So if you want to know if something is an S3 object type, you have to ask, is it an object? And it needs to come back true. And then you also have to ask, is it S4? And it has to not be an S4. Okay. And then that will be an S3 object type. All right, so we have so data frames. Data frames are an object. Data frames are built out of lists. The base type is the list, but then it's class data frame. Okay, so we can say, is it an object? That's true. Is it an S4 object? That's false, right? Okay, and the data frame here, X is that's not an object. Okay, and then they changed the default behavior of data frames. If y became a factor would be an object. Okay. All right. Here is a function. Okay. The function is mean, and the mean function is an example of a generic function. Okay. So the way we can tell if something is a generic function is you're going to see in the definition of the function, you're going to see something called use method. Okay. Use method is basically what R uses for method dispatch. Okay. So S3 methods don't belong to objects or classes. They are generic functions. Okay. Which is, in contrast to encapsulated OOP. And again, you can tell it's a generic function because it's going to say use method. So again, if you ask for mean, you're going to see use method. So other functions that are generic, right? If I say summary, you're going to see use method summary. Okay. Whereas standard deviation, that's not a generic function. Okay. Standard deviation is there's no use method here, right? So if you type in the name of a function and you don't have any parentheses, you get basically the class definition, or the definition of the function. If you see use method inside the function, it's a generic function. Okay. All right, so there is a special internal generic, okay, like sum. So sum is, so if you ask for sum and you do this, you get dot primitive, and that's not quite an internal function. And then also if you do like square bracket, these are primitives, okay, that's technically a function. And they use this dispatch group, and they're internal generics, okay, but then it's too much to worry about here. Okay, so the way we can think about this again is you have the generic function, and then if you have a specific version of that function that applies to an object, it's going to have the name generic.class. Okay, so for example, we have the mean function, which is a generic, and then there's a version of the mean function that applies for date objects. Okay, so if there's a class date object, okay, mean.date will apply there. Okay, and then you have the print function, which is a generic function, and the print method that works for factors is going to be print.factor. So so if we ask for print, we have use method print, and then I can do print.factor, which is a specific version. Okay, and this is what print.factor actually looks like, right? This is the full function definition of print.factor. You can see it's fairly complex, and this is how it's going to print things out onto the screen. When we say print out this factor, basically it's printing it out like this, right? So let me see, print.factor on y will give me that, print.factor on x, this gives me an error. It says factor levels don't exist here, but this is it's trying to print out x as a factor, even though x is just a character vector. Okay, so because it uses this form generic.className to kind of do things, most style guides will discourage the use of dots in function names. So for example, there is a function in R called t.test, okay, and this will perform a student's t-test. But the way it looks is it looks like the function t, it's a method for objects of class test, but that's not the case. That's not the case, okay? And then there's also a function called print.data.frame, and we know that this is the print method for data frame objects, okay? We know that that's the case, okay? But it could also, somebody could be confused and they could say, is there a print.data method for a frame class object? And it kind of looks like it could be that too. But we know that it's the print method for a data.frame object. But anyway, there's some ambiguity. So most style guides will say use an underscore instead of a dot. So you'll see function names like read_CSV, as_Tibble, and things like that. Okay, there's a function or package called prior, and this will look into whether a function is an S3 generic or not, or something like that. And so there's a function called is S3 generic, and you can say is the function t-test an S3 generic, and it's going to come back true. And if you do have an S3 generic, you can ask for what are all of the kind of the versions, the methods that exist for t-test, right? And so if you do t-test, there's two forms of t-test. There's the t.test default and t.test formula, okay? So here, let me just zoom in just a tiny bit more. I could ask for methods, t.test, and it lists them off. We can ask for what are the methods for the print function, right? Print, and there's like 207 print methods because we've got a whole bunch of different types of objects. So as far as print goes, you can have print.anova, print.aov, print.arima, print.by, print.check compiled code. I don't even know what half of these things are. Print.dist, print.default, print.date, print.glm, print. All sorts of different things, right? So these are, we don't have to remember all of these things. We can just use print and all of these, and R will figure out exactly which specific method to dispatch, okay? We can ask for what are the methods that exist for the summary function. We talked about summary. And so you have, 35 different things. You have summaries, you have the default summary, but you got a summary for a data frame. You've got summary for LM, summary for GLM, summary for factors and things like that. So depending on the input object, R is going to dispatch a different version of each of these functions here. Okay, so again, you can tell it's a generic function because if we just ask for the definition of t-test, it says use method. Okay. There's another function, right? So as far as t goes, okay, we have t.test, which is the generic function for t-test, but then there's also the t function, right, which we use to transpose things, right? And so if we ask for, methods on the function t, we have the default t, which is going to be used for matrices, but you can also transpose a data frame. And so you have t.data frame. You also have t.ts for time series objects, okay? So, so you have t.data frame, which is going to be a method of the t function, right? So you got t.data frame, t.default, time series, and different things, gtable and stuff like that. So here we have the function t, and the way it behaves depends on the object. So here X is a matrix, okay, and we call t on X, and it transposes the matrix. So normally when you fill out a matrix, it goes 1, 2, 3, 4 down the columns. And then here I've used t to transpose the matrix. And so now it goes 1, 2, 3, 4 across the rows. Okay, I can make a data frame. Okay, I can make a data frame out of this, right? And I could ask transpose the data frame using t. Okay, and again, R understands that the input object is different. Back here it was a matrix, and over here it's a data frame. And you might not have even realized that this function that created this thing is actually an entirely different function from here, because the behavior is similar, right? Transposing a data frame and transposing a matrix, like intuitively, it feels like you're doing the same thing. But internally, what's actually happening is very different, right? If you think about how is a data frame structured, a data frame is structured as a list, okay? Whereas a matrix internally is structured as an atomic vector with dimension attributes, okay? And so the function that transposes a matrix, which is an atomic vector with dimension attributes, and the function that transposes a data frame, which is actually a list, the internal workings are quite different, okay? So if you actually ask for what's the inside of t.data frame, actually, well, it's not too complicated. First, it has to convert the data frame as a matrix, and then it calls t, right, to transpose it, and then the internal thing is t.default here, but which is an internal, I guess, C code thing. But internally, what we have to do is we have to convert the data frame into a matrix, right? And as.matrix itself has its own kind of use method code. So we can ask as.matrix on data.frame. And this is actually quite a bit of code involved as far as converting a data frame into a matrix, okay? So there's a bit of work there to convert the data frame into a matrix, but once it does that, then it transposes it, okay? All right, okay, so yeah, there's a question. I always thought these kinds of functions had a bunch of if statements for each input type. Yeah, that kind of makes sense. And basically it's all internally handled by that use method, okay? Use method is, well, this is for t-test, but use method figures out which kind of input type you have, and R figures out how it's supposed to handle it here, okay? So when you apply T to a data frame object, it calls T.DataFrame, which converts the data frame into a matrix first, which itself has a bunch of methods and stuff like that. And then it converts it to, and then it transposes it. Okay. I realized I had my chat set so you can only chat to me, but now everybody could chat publicly. Okay. And again, we've seen this already. What kind of methods exist for a generic function? We've got that. Okay. You can also kind of list all the generics that exist for a certain class. So you could say methods for class, for time series, and what are all the methods that exist for time series objects? And these are all kinds of the functions that exist. And so you have aggregate and diff and plot and all sorts of stuff like that. All right, so let's just talk about creating an S3 class, okay? So there's one way you can use the structure function. The structure function, you create some object. So here I'm just creating a list with the word apple in it, and we're going to say this belongs to class fruit, okay? And it's just kind of on the fly. You don't have to ahead of time tell R, hey, just so you guys know, I'm going to be making, you don't have to define this class fruit ahead of time. You can just do it on the fly. Here I say, let's make a new structure, and this structure will be called fruit, okay? And then R understands, okay, now we've got a new class called fruit, okay? You can also do this, you can use it using the structure function. You can also just do it on your own. You can just say, hey, let's make an object, Y, and it's going to be a list that contains the character banana, okay? So we're going to just create this list with one object in it, character banana. And then we say, oh, you know what? Let's change the class of Y, because when we first do this, there's no class. It's just the type of is a list. And then later on we say, you know what? Let's give it a class attribute. And that class attribute is going to be fruit, okay? So now we have a new class defined called fruit, okay? I mean, defined loosely, we just kind of created a new class called fruit. And R is okay with it. It's just this very loose kind of on the fly, let's make new classes as we go, okay? And so later on, you can say, all right, well, what is class X, right? What is class X? And R goes, oh, class X, class of object X, it's fruit. Yeah, that's what you told me. You told me X is a fruit object, so there it is. It's a fruit object, okay? And then you can also just ask, does X inherit from the fruit class? And R says, yeah, that's what you told me. X is a fruit class object, so X inherits from fruit class. Now, R has no idea what fruit class is, but we just said, yeah, there's a thing called fruit class, and it works, right? So the class of an object doesn't necessarily just have to be one thing. So here, we just said X is fruit class, but you can also have a vector as far as the class goes. So if we look at, so there's the data frame, or it's a Tibble. Tibble, the diamonds data set is a Tibble, and a Tibble is has a vector for its class. If you say, what's the class of this thing? It says it's a Tibble DF, it's a Tibble, and it's also a data frame, okay? You have an ordered factor. An ordered factor has a vector for its class. The first type is ordered, which is basically a certain type of factor. and it's also a factor, right? So basically everything that applies to factors will apply to ordered factors. And then there's also special things that the ordered factor does. And so, you know, we also want to kind of specify this, right? Just kind of like if we said, you know, how would you kind of, you know, as far as geographically identify, right? If you're living at UCLA or something, you might say, well, I would consider myself a Angelino. That's somebody who lives in Los Angeles, right? I would also consider myself a Californian because we live in California. I would also consider myself an American, somebody who lives in the United States or something like that. And so you're kind of, you know, what rules apply to you, right? Like what laws and things like that apply to you, right? If there are local laws that apply to Los Angeles residents, those laws would apply. But also all the laws that apply to Californians apply, right? Like you'd have to pay like California tax and I don't know, whatever rules there are that apply to California and stuff. And then also kind of the rules that apply to American citizens and stuff like that would also apply, right? So somebody living in Los Angeles would, you know, all kinds of those, all of those things would apply. And so I don't like to use the word class here, but just it's not that strange that you could have a kind of a vector of like what functions and what verbs apply to a certain certain object. Okay, and so we can say, you know, does this vector diamonds $ cut, which is an ordered class ordered and factor, does it inherit from factor? That will return true, right? We can also ask which would be preferable, right? So if you say, because if you want to do is diamonds cut a factor, you might be tempted to do this, class diamonds equals factor. But if you do this, you're going to get a vector that says false, then true, right? Because this thing is a factor, or is a vector that says ordered and factor. And so you might be tempted and you say, is this a factor? And if you do class equals factor, you're going to get a vector that says false, true. So the preferable way is to say inherits. And if you do inherits factor, it's going to return true, that it inherits from factor. Okay. Most of the classes, S3 classes that have been implemented in R have a constructor function, okay? And this is just a way to kind of create objects of that thing, right? And we're familiar with this. Basically, if you want to construct a factor, there's a function called factor, and basically you build a factor out of it with this function, right? If you want to create a data frame, there's a function called data.frame, and that's going to build data frames, right? And these kinds of functions are called constructors. And so if you wanted to create a constructor function for class fruit, it would make sense to create a function called fruit. And basically, and this would be a really silly function to create, but this will create a structure. It will create a list of whatever X you put into it, and it's going to say class fruit, right? So we can say, let's make Z. Z is going to be fruit pineapple. And now Z is basically a list that contains the word pineapple, and it has the class attribute fruit, okay? Now, as far as classes go, R is very loose, and it doesn't, like you can just change the class of a thing, right? So here, I've created a linear model. I said LM. So LM not only creates linear models, but it's a technically constructor, because what the LM function does is it returns objects of class LM, right? We haven't talked about LM in this class, but I'm assuming you guys have encountered this before in like 101A or some other class, right? So you create a linear model, and this is a constructor. It creates an object of class LM. And therefore, when you call print, it has its own version of print. And this is how it prints out LM objects, okay? Now, this is a bad idea, but it doesn't throw an error. you can tell R, you know what? The output here, LM cars, the output, let's change the class of that to a data frame, okay? Don't do this, but you can, right? You do this and R says, okay, it's a data frame. And then you say, print this out, right? And now R doesn't know what to do. It says, okay, it's a 0-row data frame, right? It's a 0-row data frame. And these are the column headings, coefficients, residuals, effects, rank. And you're like, oh no, what happened? What happened to the coefficients? The data is still there. If you ask for LMMT cars $ coefficients, that data is still there. It's just R doesn't know what to do when you say print out this thing, because it thinks it's a data frame, but really it's an LM class object. So you know, this is not a good idea, right? So there's no validation as far as the S3 class goes. There's no built-in validation. You tell R, hey, take this object, you know what, let's call it a data frame, or let's call it a factor, let's call it something else. And R allows it to happen, okay? But this is not a good idea, right? You shouldn't do it, right? R is not going to protect you from yourself in this regard, as far as changing classes. All right, let's talk about making methods, all right, and generic functions, right? So if we wanted to create a new function, a new generic function, all we have to do is we just use this kind of this magical function called use method, right? So use method takes basically two arguments, the name of the generic function, in this case, quotation, and the argument to use for the kind of the method dispatch, right? So so basically here, you know, you generally want to make this have the same name as this, okay? And you don't need to kind of pass anything to use method. Hadley Wickham says this works by using deep magic, so we're not going to worry about it. But yeah, this is how we define a new generic function. All right, so we're going to create a function called quotation, and this is going to just return, I don't know, quotes, return quotes, right? So if we have a fruit class object, we're going to get this quote. It's going to return, quotation is going to return a function, return a string that just says fruits are an important part of a balanced diet, right? And so here we're going to create X, which is a banana, banana inside a list with class fruit, right? So X is class fruit. And we say, give me a quote about X, and it gives me back this. Fruits are an important part of a balanced diet. Okay, so simple enough. So now we do quotation X, okay? We can also define, take existing functions, right? So mean is an existing generic function. And we can say, you know what, if somebody asks, what's the mean of a fruit class object? Just say it's the number 5. I don't know what this is supposed to do, but we can just say, okay, well, what's the mean of X? And then, and R goes, yeah, well, that's a fruit class object. So the mean of a fruit class object is just 5. The mean of X is 5, right? There's no check that just makes sure that this makes sense at all. It just says, R says, oh, okay. Fruit means are 5, sure, let's do it. And they do it, okay? The way it works is when you do use method, it's going to take the generic name, in our case, mean or quotation or whatever it is, and then it's going to take the class name and it's going to search for a function called mean.fruit or quotation.fruit, okay? And then there's also something called default. So if it doesn't find it, it's going to search for, you know, mean.default as well. Okay, so here I've got a few methods. All right, we're going to have quotation, use method quotation. It's going to look for whatever it is. We've got quotation.fruit, quotation.apple, and then we're going to have quotation.default. Okay, and so if it's an apple, we're going to say an apple a day keeps the doctor away. And then generic quotation, the default quote will be, let food be thy medicine and medicine be thy food. Okay, so let's let's try this, right? So we're going to create A, which is going to be a Fuji, and its class is going to be this vector, apple and fruit, right? And so when we do quotation on A, it's going to find the apple class. It's going to say, is there quotation dot apple? And yeah, there is quotation dot apple. And so it's going to do an apple a day keeps the doctor away, right? Here we've got Chiquita, and that's going to have class banana and fruit. Okay, class banana and fruit. And so first it searches for quotation dot banana. And there's no quotation dot banana. All right. And then it says, okay, well, the next thing in the vector is fruit. So it looks for quotation dot fruit, and it goes, ah, yes, fruits are an important part of a balanced diet. And that's what it gives us. Fruits are an important part of it. Okay. And then here I've got Duncan, and its class is going to be donut. Okay. So it's going to look for quotation dot donut. It doesn't find quotation dot donut. So it's going to go to quotation dot default. Okay. And then so it gives us the default quotation about food and medicine. All right. Now, if you want, again, here's B. Okay, B is a banana, right? And so by default, quotation on B is going to look for a quotation banana and doesn't find it, and it uses quotation dot fruit, which gives us this. Now, if you wanted to, you can call quotation dot apple on object B, right? Now, this doesn't make sense, but you can say, I know it's a banana, but I want to hear the apple quote, is basically what you're saying. So you can do quotation dot apple, and it gives you the apple quote. Okay. So this is silly. This is like changing the class of the object. But you know, if you wanted to, you can force R to call the wrong method. So you know, not a good idea, but if you want to do it, you can do it. Okay. Now, if we remove the default method, right? Quotation dot default. If you remove that, if that's no longer there, when R searches for this donut, right? It looks for quotation dot donut. It doesn't find it. And so it searches for quotation dot default, and it gives us an error. It says no applicable method for quotation. Okay. And it's also going to say there's no default method. So it tries to look, but it doesn't find quotation dot donut. It doesn't find quotation dot default because we just removed it. R gives us an error. Is that all right? Any questions about methods in S3 methods and these default things? All right, let me go ahead and give you your second view quiz answer for today. Today's second view quiz answer is the letter C. C as in cat. C as in cat. Okay. So we have inheritance. Okay, so inheritance will, you know, we talked about how one class can inherit the kind of the class definition from another class. Okay, so give me a second here. Okay, so as far as inheritance goes, right, the class of an object can be a vector. And basically the way it works is if it doesn't find a function or method specific to kind of the first object, it goes to the next thing, right? And you can also use a function called next method, right? And so so let's kind of look at this, right? So we can look at S3 dispatch, which is a function from prior, and it's going to say, you know, it found the method, or it goes through the next one using next method. Okay. So, you know, let's just take a look at how this works, right? So as far as print goes, okay, so here we create a factor. It's an ordered factor by doing factor letters, and we say ordered equals true, and there's no print.ordered, okay? So when we ask for methods of print, there's no print.ordered. Despite all of these things, there's no print.ordered, okay? We have a print.factor, but there's no print.order, right? So if I create the x is here, and if I say y is going to be a factor of x, and we're going to do ordered equals true, right? So here's x, and we say, I'm sorry, class y. Okay, class y is an ordered is an ordered type and ordered class and factor class. And so when we ask for print on print y, it gives us this, which is different from, and it's printing using the factor method. Okay, and so it's going to do print.factor, which is different from print.default. Okay, print.default, we could force that. Print.default y, and it outputs 1 and 2. Outputs 1 and 2. And why is that? Okay, because if we do type of y, y is a factor, but it's an integer type, right? And so if I do as.integer on y, then it'll produce this output y. Okay, but when we do the print.factor on y, it gives us this. Okay, so if you force the default printing method, which prints it out as an integer, it comes out as 1, 2. So the ordered class is a subclass of factor, and factor would be a superclass of the ordered type, ordered class. Okay, there's no formal restrictions. Okay, but basically the subclass should be the same type as the superclass, and the attributes of the subclass should contain everything of the superclass and maybe a few more. All right, here's a self quiz that you can do. But again, you're not going to be tested on this. So here, we'll do like one of these just for fun. And then you can go through these just for fun also. But this is basically how method dispatch works, right? So here I'm just clearing the environment. F is going to be a generic function. We're creating a generic function for use method F. Okay, f.j is a specific method of F that applies to class J, where we're going to take X and add 2. F.k is a specific method of F where we add 10. And here I'm creating just an object K, which takes on the value 1. And if I do F on K, what's it going to do? It's going to error out because it's going to look, because K is just an integer type double, and we don't have f.default. Okay, so this gives me an error, right? Because it's looking for f.double, f.numeric, and tries f.default, and there's no f.default defined. So this is going to give me an error. Okay. Here we're going to assign K to class J. We're going to say this is a class J. Okay, K is the value 1. So when we do this, it's going to do f.j, because it's class J, and it's going to add 2. So now it's going to give us 3. It's going to give us 3, and it's going to say it's class J, right? So the output is 3, class is J, and it says, oh, look, here's f.j, and it dispatches that. Okay, well, anyway, there's more to the self quiz. I think it's kind of fun. I think method dispatch is a pretty interesting topic, but just kind of for simplicity and time, I'm skipping it all. Okay. There's a lot of good stuff there. But again, I don't know, the threat of you not being tested on it has been taken away. So I hope you will just find the motivation to go through those slides on your own. Okay, let me talk about the other object-oriented system that I want to talk about, which is R6. Okay, and we'll spend the rest of today's lecture that. I'm pretty sure I'm going to run out of time to go over ggplot. So these slides exist, and you'll have to kind of go through them on your own, which you'll need for the upcoming homework assignment. Okay, I used to if you were taking this during a 10-week quarter, have a homework assignment using the R6 object-oriented system where you kind of have to program the rules of Monopoly as far as like moving your pieces around the board game. It's a pretty involved homework assignment. It takes a while, and I've gotten mixed reports from students. Some students enjoyed it, some students hated it just because of how time consuming it was, but it uses the R6 object-oriented system. But kind of with our compressed time schedule in summer session, this homework assignment will not be given to you. So sorry to disappoint you there. But anyway, I still want to cover the R6 object-oriented system. Okay. The R6 uses the encapsulated object-oriented programming system, which is a little bit more common as far as other programming languages go. So, other programming languages like Python and C++ use OOP. Use encapsulated OOP. They don't use generic functions. Instead, the methods belong to the objects themselves. The methods belong to the objects. Okay. And R6 objects are what we call mutable, meaning they can be modified in place, and they have what we call reference semantics. Okay. To get this working, you got to load up library R6. And if you don't have that installed, you got to install it first. And let's just kind of talk about this. So as far as R6 class goes, you create a new class using R6 class, and you need at least 2 arguments. One is going to be class name, which is going to be the class that you are creating. By convention, we use upper camel case, which just means if you have multiple words, each word has a capital letter, and no underscores and stuff like that. And then you have a public list of methods and fields. There's also private methods and things like that, but we won't get into that. Okay. And as far as public fields go, we call these, we use snake case, which means you use underscore and everything is lowercase. Okay. You should always assign the result of an R6 class into a variable with the same name as the class. So whatever class name you're using, the R6 class should be assigned there. Okay. So for example, we're going to create a class called accumulator, and its class name is accumulator, right? So the class name is accumulator. We're saving it into an object called accumulator. And we're going to have a public field, which is a list of 2 things. Okay. One is the sum, which is a number, and that's going to be what we're storing. And then we have a method called add. All right. And we know it's a method because it's a function. So inside public, we have 2 things. One is a value. That's the field we're storing. And we have a method called add. And as far as add goes, we're taking the value inside here, which we reference with $sum. We're going to add whatever x is. That's a function of x where the default value is 1. We're going to add it to this. We store it back into $sum, and then we return the self invisibly. Okay. We'll get into this function definition in a moment here. All right. And so when you say, okay, what is an accumulator? It says, oh, this is an object generator, as in we use this to generate objects of the accumulator class. All right. And what is it? There inside public, we have sum, we have add. Okay. And then pretty much all R6 classes come with a few other functions like clone and things like that. All right. So if we wanted this to work, we say, you know what, let's make a new instance of the accumulator class, and we're going to call this X. So X is a new instance of the accumulator class, accumulator $new. And all right, so X is an accumulator. All right, so notice this is different from the accumulator object generator. This is X is an accumulator. So this is not going to generate new accumulators. This is an instance. This is one instance of the accumulator object, right? And right now, the accumulator object has the function add. It's got a value sum. It all R6 things kind of inherit this clone function, which allows you to make copies of it. Okay. All right. And so we can say, well, what's the current sum? The current sum of X is 0. All right. We can say, all right, let's let's take our current sum, which is 0. Let's call the add method, $, add. Okay, what's the sum? The sum is now 1. Okay, let's call the add method and give it the argument 3. What's the value of sum? Sum is 4. All right. And all we're doing is we're just adding values to this, right? So again, if you look at the definition of the method that we defined inside accumulator, we said this is how the function works, right? The function takes some argument x, the default value being 1, and it takes the value stored inside itself, okay, which it refers to itself as self, right? So x, whatever's inside of x, inside that environment, we have the value sum. Add on x, store it back into itself, and then it returns self invisibly, okay? And basically it, and this invisible thing means the object is returned, but it's not going to print out. So back here when I did $, add, like nothing happened afterwards, right? Nothing happened after I did $, add. If I wanted to see what the sum was, I had to ask for it explicitly. Okay, so I did $, add, nothing happened, $, add 3, nothing appears on the screen, I should say. It added 3, it added 1 here, but nothing appeared on the screen. If you wanted to know what the updated sum is, you have to ask for it explicitly, okay? But by returning itself invisibly, it allows you to kind of what we call chain the methods. It allows us to chain these methods. So here's my current sum, which is $, sum, and that's it's currently the value 4. And so here I can do $, add 10. At the end of add 10 is we've returned itself, okay? And now, it has the value 14. And because we've returned itself, we can call the add method again, okay? So we call the add method again, and we can say add 10 to it. And so now it takes on the value, the sum takes on the value 24, and we can ask, okay, and what's the value of sum? We can ask for $sum, and we get the number 24 there, right? So we call add method to this, and we're chaining the methods, right? Because each of these methods returns itself invisibly, we can continue to just call any kind of function or method that belongs to this object, right? So we can continue to just keep chaining these methods together because each time it's returning itself. Does that kind of make sense there? This idea of method chaining, because it's returning itself, the methods that exist in that object class can be called. If you've ever done object-oriented programming in Python and things like that, this idea of method chaining, I think, is familiar to you, right? So like you can take a list and you can, like list this and list that, and continue to kind of chain these methods. Okay, so for readability, if you wanted to do a whole bunch of methods together, sometimes it's recommended that you put the chain methods on their own line. So you have $, and you can do add 10, $, add 10, $sum, and then we get back 4. So we've added 10 twice to this, our object X, as it just continues to accumulate values. Okay. It's often recommended you create an initialize method, okay? Because you can always call $new, okay? But $new will just create with the default values defined. And if you want to have a way to kind of put values into your thing from the start, you need an initialize method, okay? So here we're going to create a class of person, okay? We're going to create a person class object, the person class. And as far as the person goes, we're going to just have 2 things. We're going to have a name and we're going to have an age, okay? And the kind of the generic default values is no null and age is missing, okay? And then what we need is we need to say, all right, let's create, when we create a new function, we need to have the name and we need to have an age, okay? And so we're going to say, okay, first we're going to just do a check to make sure that the name is character and that it's a length 1 vector. If it's longer than that, we're going to have problems. Okay, we're also going to check to make sure that age is a numeric value and it's a length 1 vector. And if that's all good, okay, it's going to say stop if not, so that these throw errors if these things are not true. If that's good, take the name that you came in when you did so initialize will basically run when you do person $new, okay? And we're going to say, okay, well, take the name and store it into self $name. Take the age and store it into self $age. Okay, so here we're going to say, all right, let's make a new person called Hadley. And we're going to give it the name Hadley and age will be 30-8 as a character. And it says, no, you can't do that because age is not numeric. Okay, so we're going to say, okay, fine. Let's create a new person where the name is Hadley and the age is 38. And that works, no errors thrown. Okay, it just creates a person there, right? And so, so again, even though it's called initialize here, it gets run whenever you call $new. Okay, so once we've done that, we can say, okay, well, what's Hadley? So Hadley is an object, an instance of the person object, okay, or person class object. And we've got age 38, name is Hadley, and there's the clone function, and there's the initialize function, okay? If we don't like how this works, we can define a print method, okay? And it's going to change how this works, right? So here, we're just expanding our class definition. And so we're going to create a print method, okay? And so anytime we ask to print out a person, we're going to say, okay, cat person to the screen, cat the name colon and self $name, cat age colon and self $age, and return itself invisibly. Okay, so when we do that, let's create a new instance of person. We're going to call this Hadley 2. Now we have person, name is Hadley, age is 38, like that. Okay, and so this now runs, okay, the $print method runs anytime we call the thing, right? The default print method for an R6 class looks like this. This is a little bit too much. It's not as nice. So we've cleaned it up and we've defined our own print method here. Okay, which looks like this. So I think that looks good. And so one thing to remember though is that the objects you've created are bound to their definition. So back here, so Hadley 2 was generated under this new definition of person, which included the print method, okay? Whereas this object, Hadley, was created under this definition of person, right? So this definition of person doesn't include the print class or print method, whereas this definition of person does. Hadley 2 was created from the definition that includes the print method, whereas Hadley itself, Hadley without the 2, was created from the definition that didn't include the print method, right? So when you ask for what's the definition of Hadley 2, these are both person class objects, but Hadley 2 has the print method. Hadley, the original here, doesn't come with the print method. And so the way they print out is different, right? These refer to their original kind of class definitions. Okay, and even though these both have person class, they are of person class, there's actually no relationship between Hadley and Hadley 2. Okay, between these two things, there's no relationship. They happen to have the same class name, and R doesn't get angry about that. R is just like, oh yeah, you called this thing a person class, and that's good. And then you called this thing a person class, and okay, that's fine. And and R doesn't complain, okay? Now, it can become confusing to do something like that. So if you are working on a class definition and you update your class definition, it's a good idea to go back and delete all of the other objects created under the old class definition, just so you don't kind of run into this problem, right? It's kind of like, you know, every year they release a new model of the same car, right? So you have like a Honda Civic from 2020, and you have a Honda Civic from 2012 and a Honda Civic from 1995, and they're different cars, okay? They look different, they have different features and things like that. You know, we just happen to call them Honda Civics for all of them, but you know, the way you would fix the one from 1995 is going to be the way, you know, different from the way you fix one from 2020 and things like that. And so, you know, they just happen to have the same name, but they're different, okay? And similarly in R, whenever you update the class definition, the old things don't suddenly get updated at the same time, okay? If and it, you know, you don't have to, it might be a good idea to throw them away, right? And recreate new objects of these things. All right, you can modify fields and methods of an existing class. You use the $set, okay? So here we can just kind of change the sum value back to 0. Or I'm sorry, here, okay, I'm sorry. We're going to create a new accumulator class object, and then we're going to set the sum equal to 0. We're going to set the definition of add, okay? And that's going to add these in there, okay? And again, this is only going to be available to the new instances of this, right? Here we are going to create an object called accumulator chatty, all right? And this inherits from the accumulator, okay? So here's our accumulator class, which has the sum and this add method, and we're going to create a chatty version, okay, that inherits from the accumulator, right? So what's it going to do? Well, this version basically takes all of the same information from before, except the add method is a little bit different. The add method is going to cat onto the screen this message, adding X, okay, adding X. And then notice this, we call super $add. What is super, okay? Well, we have, you know, self, which refers to kind of any kind of field or thing method that exists in the self definition. But here, because we're inheriting from the accumulator class, super refers to the kind of the parent class that we're inheriting from. So we're saying, you know what, we don't want to actually redefine the add method, which takes self $sum and adds X to it and returns self invisibly. We want that the same. And rather than just copying and pasting this in here, we're going to make a call to that add method in the super. Okay, we're going to do super $add. Okay, and so this calls this method back up here. Okay, so it's pretty much the exact same function, except we've added this line where we're going to do this, right? So here we're going to create X2, a new instance of the chatty accumulator, and then we call $add 10, $add 1, $sum. And because the chatty accumulator, it's going to cat adding 10, it cats adding 1 to the screen, and it returns 11 now. All right, okay, and so this just goes into detail about this super, okay? Super $add. And over here, okay, as far as the list of methods go, we only gave it a method for add. We didn't give it a method for print or anything like that, okay? And so, so any kind of other methods or actually, well, there's only one method here, but if we created a method for print or something like that in the parent class, and I didn't create something like that, any methods that are not overridden, you will use the implementation that exists in the parent, okay? All right, so here, you can always ask, what's the class of something? All right, class for Hadley inherits from person in R6. Hadley 2 also inherits from person, which, technically has a different definition and inherits from R6. X2 inherits from accumulator chatty and accumulator and R6, okay? And again, these definitions of person classes are different, but R doesn't do any kind of check there, right? And again, so it could get confusing. You should probably delete the old versions. All right, you can see any kind of methods and fields that exist for a class. So when we did names Hadley 2, it has the age, okay, and age and name, okay, and it also has an initialize method defined. It also has a print method, but it didn't get printed out here for whatever reason. It's like it got cut off. Print should show up here. I don't know what happened. Okay. All right. And then and R6 things have what we call reference semantics. Okay. So one thing about reference semantics is it's different from what we're accustomed to. R always kind of does copy on modify, right? So here, if I do A is the vector 1 and 2, and we say B is A, and I take B and I add 10 to the first value and set it back to the first value in B, R creates a copy when it does this, okay? So A remains 1, 2, and B, this first value becomes 1 plus 10 or 11, and so B has 11 too. So this is the default behavior in R, copy on modify. You try to change something, it creates a copy and it modifies that thing. Okay, so here A is 1, 2. If you say add 10 to the first item in B, it does it, but it only affects B. Here, with reference semantics, you get something like this, okay? So X is going to be a new accumulator class object, which means it's going to start off with the value 0 for the sum, right? Here we're going to say Y gets from X, okay? We're going to take X and store it into Y. I'm going to add 10 to Y, right? So the sum starts off at 0. So if I add 10 to the sum in Y, and we ask, well, what's the sum in X? The sum in X is now 10. What's the sum in Y? The sum in Y is now 10, okay? Both of these things are referencing the same object, okay? Y and X are pointing to the same thing. So when we added 10 to Y, X also 10 got added to that because they're pointing to the same thing. Y and X are basically two names for the same object, okay? So it's not a copy. Y and X are two names for the same object. If we don't want that, we have to use clone. So here I create a new object for X, which takes on the value sum is 0. And then I'm going to make a clone. Okay, I'm going to make a clone. We're going to call that Y. Now I add 10 to Y. I say Y add 10. This value becomes 10. I ask, what's the sum over here? It's still 0. Okay, X sum over here is 0. Y sum over here is 10. Okay, so again, if you just do this, it doesn't create a copy. Y and X, it's the same object. Y is pointing to this thing, X is pointing to this thing. They're two names for the same thing. If you want a separate thing, you got to use the clone method, and it creates a copy of itself. And now they're pointing to different things. You can add 10 to Y, and it doesn't affect X because they're pointing to different things. Okay, sometimes reference semantics can be tricky. All right. So here, X is going to be a list with A equal to 1. Y is a list with B equal to 2. All right. And Z is going to be the result of running F on X and Y. Okay. So if this is regular base R, no reference semantics, we know that we take F, we input X, we input Y, and it's going to output Z. Okay. In base R, we know that X and Y are not going to be modified when we run F, right? They are going in as arguments, but we know that functions in R generally don't modify anything that happens to the arguments. It produces something and it outputs something, okay? But if you have reference semantics, okay, with reference semantics, so now I have capital L list. With reference semantics, this function could take X and make changes to it. This function can take Y and make changes to it, right? And then the function also returns a value and stores it into Z, okay? And so later on, if you say, well, how did my value over here, how did I suddenly end up with a 10 over in the Y sum? It could have happened when you run this function. You could have also modified it somewhere else. It's a little bit harder, right? So within the function, there could be calls to the methods that modify X and Y directly, right? So what gets modified is a little bit less clear, and it can end up being confusing, right? So one tip is when you write a function, you have to decide whether it should return a value but not modify any of the input values, or if it'll modify the input values but not return a value. Okay, doing both can lead to be confusing, right? So here, add 10, this doesn't actually return a value. It returns itself, right? It doesn't return a value. So this, when you see something like this, you can say, oh, it's going to modify itself, not return a value, okay? Whereas other functions that return values, you can say, oh, this is returning a value, it's not modifying the inputs. Those are kind of the guideposts. But again, there's no rule that enforces it. So if you wanted to write a function that both modifies the values and returns a value, you can do that, but it can get confusing, okay? So here's a function called add 5 to sum, okay? And we're going to add 5. This modifies in place. No, doesn't return a value. So we can take X new instance, we can call add 5 to sum X, and now X takes on the value 5, right? Here it's going to return the sum times 10. And in order for us to get this is going to return a value and we have to store it. So we can do sum times 10 gives us 50, doesn't modify X itself. So X $sum remains 5, okay? Value of good practice, okay? R6 has private fields and active fields. I put this won't be tested on the midterm exam. Oh, that's because these are my slides from the previous lecture. And it's not necessary for the homework. You're not even getting that homework. Okay, so don't worry about it. But you have private fields and public fields and active fields, okay? So let me just kind of show you how this works, okay? You can have methods and fields known as private. These are only available inside the object, and they're not available out from outside. So you can't modify values inside a private field from outside the object. You can only modify them from inside, okay? Now, private doesn't mean secret, okay? So like, don't try to like create an object and say, oh, I'm gonna make this private, and that means people can't access it, right? Like if you're gonna like create a social security number in there, you know, people can still view it, right? So private doesn't mean secret, it just means it can't be modified from the outside. So let me just kind of show you. So right here, excuse me, we have name and age as a public field, okay? So when we created a person, you know, Hadley's age is 38, But if we wanted to, we could just say Hadley age is now 25 and Hadley's age is 25, right? So this is a public field. We have access to it from the outside, right? We can just directly assign values to Hadley $2 age. And maybe you don't want this, okay? Maybe you do, but maybe you don't. So if you don't want that, you can use private, okay? So here, instead of using self and stuff, we're going to say initialize name and age. We're going to use private $name, private $age, and then when we make a call to print, it's going to call private $name, private $age. It's going to print those values out, and we store age and name inside private. Okay, and so here we can create a new person, Hadley 3. Hadley 3 has the name Hadley and age 38. Okay, and if you ask, well, what's Hadley 3's age? It comes back and it says, nope, I'm not going to tell you that. It doesn't give you access to it. Okay, you don't have access to getting the age directly from the outside. Okay, you can say, I want to take 25 and assign it to Hadley 3's age. And it says, that's not allowed. Okay, you're not allowed. You can't access that field. Okay, but those values do exist. They're only available from inside the object. So when you call print, when you say print on Hadley 3, right? Because print is a public function, right? And we're not explicitly calling print, when you just type a name of the object, R implicitly prints it, okay? So when you call print, you have access to private name and private age from inside the method. And so we can get, okay, the name is Hadley and the age is 38, okay? So those values are available from inside, but only from inside the function or inside the class. Okay, is that all right? As far as how a private field works, it just prevents you from accessing it directly from the outside. All right, it stores it inside. You can't mess with them from the outside. So then you also have active fields. Okay, active fields look like a public field in that you can kind of access them from the outside. Okay, but the values are actually defined by a function, okay? They're actually defined by a function. And so the active field is going to be created by, you create a function that has an argument value, okay? And that argument value sometimes will be missing and sometimes it won't be missing, right? If it's missing, it means the person is asking, it's trying to retrieve that value. And if it's not missing, then it means the person's trying to modify the value, right? So here, this would be an instance where we're trying to retrieve the value, $age, we're just trying to retrieve it. Here is an instance where we're trying to modify it. We're trying to do 25 assigned to age. This would be an instance where it's not going to be missing, we're trying to modify it. This is an instance where age would be missing because we're just trying to retrieve it, okay? But again, here we're doing as an active field. So let me just show you, all right? So here is class rando, okay? Class rando, and there's one value, and this is an active field, and the active field will give us, if it's missing, it's going to return a random number, and it's going to say, you know what, you're not allowed to set a value here. So if it's not missing, that means we're trying to modify it, and it's going to give us an error. Okay, so here we're going to say, give me a new instance of rando. Okay, and then we could do $random, and it gives me a random value. $random, it gives me a random value. $random, it gives me a random value. Right? These values are generated by this function, right? Because it looks like a public field, right? We're just saying $random, so it looks like a public field. In the same way we ask for like person $name, person $age. It looks like we're just asking for some value, but the numbers here are generated by a function. In this case, it's a random value, right? And then we're going to say, you can't assign it. So in practice, they can be useful to use with private fields, right? Because it allows you to have kind of components that look like fields that you can kind of just retrieve, but also kind of we can make them read only, or we can ensure there's checks to make sure that they work, right? So here, we're going to have, we're going to create a person, okay? And the name, age, and name will be stored in private, okay? But they're being stored in .age and .name to kind of distinguish, and you'll see the difference, right? So we got name and age. Those are going to get stored in private.name, private.age, okay? But we're going to have two active fields. We're going to have a name active field and an age active field, okay? And basically, if it's missing, it means we're trying to retrieve it. So we're going to pull private $.age. So the age is accessible, okay? But we're going to prevent somebody from assigning values to the age. We're going to say if somebody's trying to modify age, we're going to give an error that says age is read only, okay? And then as far as the name goes, if we try to ask for the name, we're going to get the name, okay? And then if we're trying to modify the name, we'll go ahead and modify the name, but we're going to make sure it's a character, and it's length 1, okay? So I've talked about this here. So here we're going to create, again, a fourth instance, Hadley 4, creating name Hadley, age 38, okay? And we can do Hadley 4 $name, and it gives us back the name Hadley. Okay, we can say, you know what, I want to change it to Wickham, Hadley $name. We're going to assign Wickham, and it modifies it. Okay, it modifies it here. Okay, and so now Hadley 4 $name is Wickham. No problem. Okay, but if I try to assign the number 10 to the name, it gives me back an error. It says it's not a character thing, right? And so Hadley name remains Wickham. Okay. If I ask what's Hadley 4's age, it says 38. If I try to modify it to age 20, it says age is read only, right? So these look like public fields, right? Hadley $4 age, Hadley $4 name. These give us, we're able to retrieve them, but they're actually being generated by a function. And it allows us to run these checks. Like I want to make sure we can't modify the age, or I want to make sure we're not going to assign numbers to the name, okay? Whereas back here, way back here, okay, here, if they're just public fields, you can get the value like this, right? This is useful, getting the value is useful, but then you can just also mess around with them, right? There's no check here, right? We could put in the number 25, we can put in the number, we can put in a character vector, we can put all kinds of stuff. There's no check here as far as public fields for what can be assigned into an object, okay? And maybe a private fields, perhaps we don't want this behavior, where if we do $age, it gives me back null, okay? Maybe we don't want that. Maybe we want to be able to access the age like a public field, but we just don't want to be able to mess around with it, okay? And that's where active fields come into play, okay? So we can create an active field that, will retrieve the private field, but also prevent people from messing with it, or we'll implement some kind of checks to make sure that that the values get assigned properly. Okay, and so those are active fields. How do we feel about that? It's okay. All right, let me go ahead and give you your last view quiz answer for today. Last view quiz answer for today is A. A as in apple. A as in apple is your last view quiz answer. All right, okay, so let me just kind of mention S4 and RC because we didn't cover these ones. Okay, S4 is similar to S3. It uses generic functions, but S4 formalizes those class definitions. So remember in S3, we just said, hey, I want to create a new class called fruit. And R says, all right, let's do it. Let's create a new class called fruit. Okay, S4, it's not like that, okay? You got to say, all right, here's a formal definition. This is what a fruit class is going to look like. And it's going to have these fields. It's going to have these things. And R will say, yes. Now, if somebody's going to create a fruit class, it better meet these specifications. Otherwise, we're going to say no. Okay. RC is similar to R6, okay, in that it creates an encapsulated object-oriented programming system. It's built out of S4 objects, and so you got to understand S4. It also uses super assignment, which we don't really like, but it uses that. I think R6 is the preferable encapsulated OOP system. The downside of it is that you got to load in that library here. Okay, this is where I introduce ggplot and stuff, and the lecture notes come from rgraphics.org, this rgraphics cookbook, and I get into ggplot. We don't have time for this, okay? So there's a bunch of slides here. I think some of you have already seen ggplot2 from Stats 20. Some of you have not. And hopefully these notes are good enough to kind of get you through it. I'll link to, maybe what I'll do is I'll provide a video link to kind of my old lecture that covered the ggplot notes if you want to kind of review those as well. I don't have like a formal, like you're not going to see ggplot2 appear on the final exam per se, but you will need to use ggplot2 in order to do the next homework, which will cover, plotting some root finding methods and stuff like that. The next homework is going to, I'm going to release, I guess, later this week, and I'm going to make it due Friday of 5th week. Okay. So, so this current homework is due like Tuesday, and then the next one will be due Friday. And that'll just kind of give you a little bit of extra time to kind of work on it, just because stuff that it covers will be in Wednesday's lecture and then the following Monday's lecture. So I'm not going to get everything done for homework 4 until next Monday. So the next homework will be due on Friday of next week. Okay, we'll wrap it up here for today, and I'll create a link for an older video that covers the grammar graphics ggplot stuff here. Okay, have a good evening, and we will see you guys on Wednesday.